Alright, I bought this Sonax 750G off of Facebook Marketplace for $25. It had some problems. There were no speakers in it, and it had a loose transistor back here. I replaced the transistor. The thing came alive using a test speaker. I figured, okay, great, I got myself an amp for 25 bucks. Let's see how it sounds. Before I started playing with it, I immediately replaced all the filter capacitors, and I noticed that this was happening when the amp was powering on. Turning the power switch on right now. Yep, it's dumping pure current into those speakers and exercising every bit of the duty cycle that they have. I believe this is where an NTC thermistor can come to the rescue. Yeah, so it's kind of scary. If that moment where the speaker is pushed out lasts for more than like 10 seconds, I can promise you the speaker is just going to burn. The voice coil will burn. The amp is dumping all it's got into the speaker. All right, so we're going to get some shrink tubing that can fit the thermistor, and then we're going to get some of this perforated project board that can also fit inside the shrink tubing. That will insulate it from the chassis and other ground potential when we put it inside the amp chassis. All right, we're going to insert the thermistor into this perforated board like that. That'll act as some strain relief, and it will give us two places to hook up our wire leads to from the power switch. And then we're going to take a length of shrink tubing and we're going to stretch it out inside of our wire strippers here so that it is appropriately sized to fit over this assembly right here. You get the idea. Okay, so we're going to put the thermistor somewhere in the main power switch circuit or on the plug or power cord itself. In this case, I'm going to put it in the power cord. But the way a thermistor works is when you first run power into the thermistor, the resistance is really, really high. And as time goes on, the resistance falls to like near zero. And it does that through heat. So when you first put power onto a thermistor, the heat starts to rise as time goes on. So you got these two, inverse related plots. But basically, when you first put power on a thermistor, the resistance is near infinity, and then over like 5, 10, 15 seconds, the resistance falls to near zero. And what I'm going to try and do is I'm going to try and choke the current going into the amplifier during that power on event. Okay, so I verified that this black wire right here was indeed going to the hot terminal on the electric outlet, and as you can see, I cut it right here. Here is where I'm going to insert the thermistor. All right, there you see a thermistor in place within the power cord, and then with the shrink tubing over everything so it's safe. All right, 3, 2, 1, power. That didn't seem to do a whole lot. I guess that wasn't a good idea. All right, so one thermistor didn't work. We're gonna see if 3 in series will work. Powering on in 3, 2, 1, now. Boy, it seems to be worse and not better every single time I add a thermistor. I'm gonna post this video. What the heck? Maybe some of you guys know how to help. maybe you guys know what's going on here and can lead me in the right direction to fix this problem. Maybe it's not a problem, but I for sure see straight DC current going to those speakers, and that's not a good thing. Alright, so I added that thermistor between the rectifier and the first of the two filter caps. I was reading on the internet. That was another way to utilize these things. If this ends up working out, I'll throw a link in the description. I have this, however, hooked up to a crummy test speaker that's partially burnt up. And I don't know if it's going to light on fire or have some problems. But if it does, I got my fire extinguisher right there. Alright, so we're going to power this thing on now. 3, 2, 1. That's way worse. It works. I'm gonna do what I said earlier and just put a resistor in the speaker load with a switch on it where I can dump the current through. If any of you guys know what I'm doing wrong here, can you chime in? I could use some help. You know, I've taken basic electric courses in college, and I'm pretty sure I'm not doing anything wrong here, but this is not helping this particular situation. I'm going to run through and check all the resistors and make sure that they are at the right values. That's easy to do. And again, all those electrolytics right there are new. I can assume those are okay. Yeah, like I said, I could use some help, guys. If you could chime in, let me know. There might be a better way to utilize these things, or maybe not at all. Thank you. All right, I removed the NTC thermistor after the rectifier, and I got a little, not a little, 10 watt, 1 ohm resistor across the speaker terminals as kind of a proof of concept. I'm going to turn this amplifier on in 3, 2, 1, now. Whoa, way worse. She's warm. I don't know. Powering on in 3, 2, 1. I don't believe it. So the problem all along was that transistor. That one was loose and shorted out on the chassis. I replaced it, but I left that one alone. I put a meter on it and they behaved differently, so I suspect that that might have been the problem. Alright, so the struggle is real. And then I think a good lesson learned here is that NTC thermistor really wasn't the right solution for the problem. I think the solution for the problem is finding the problem. Alright, look at all the fun you get to look forward to when you try and fix electronics.